Hello everyone. In this lecture, we are going to talk about the software development process. In this module, you will learn about the software development process, essential steps of software development process, and we are going to take a look at one of the software development lifecycle models called the waterfall model. Now, why are we learning about software development process in the object-oriented programming course? Well, here's a question that you should consider about. Is programming a tool or a goal? Well, the answer to that question is programming is a tool, not the goal. The goal is development of software. That's why in this course you are introduced to the software development process. Well, of course, software development process is a comprehensive topic, and therefore you need additional courses to understand the details of how to develop software, and we have courses for that. Now, the software development process is a systematic process that entails the development of a software-intensive product. Why are we calling software-intensive product? Because today, even though most systems include software, they also include hardware. And to develop software systems, we also have to learn about hardware and also some other disciplines, some other engineering disciplines. Now, there are many different software development lifecycle models, SDLCs in short. Now, different needs and constraints necessitate the development of different models. Well, the software development process is a generic name, and different models gets the name such as software development lifecycle models. Now, each model has different strengths and weaknesses. That's why we have different models. And each model describes a specific software development process. Now, to learn about these different models, there are software engineering courses that you can take and learn about these different models, what their strengths are, what their weaknesses are, and in which conditions they are used for, and how they are benefit to the customers and users. Now, software developers should choose a suitable software development lifecycle model based on their needs and constraints of the software. Some of the well-known software development lifecycle models include the waterfall model, incremental and iterative development model, the spiral model, racial unified process model, agile methods, and the rapid prototyping model. There are also other additional models that are geared towards more specific development types. Even though there are many different models, there are some common essential activities and phases in most models. And these activities and phases are planning, analysis, design, implementation, testing and integration, and maintenance. Now here is a graphical illustration of the software development process. As you can see, this is a circular process, meaning that the software evolves throughout the time. Well, of course, we'll start our software development process with the planning activity, and then we are going to do an analysis based on the outputs from the planning activities, and then we're going to take that design, develop the requirements, and based on those requirements, we are going to have a design for our software product. And then we are going to take that design and turn it into a software product using implementation. And then we are going to take that software product, and we are going to test it and integrated it into the platform that's going to be used, and we are going to deliver it to the customer, of course. And during the maintenance phase, if the customer requires additional requirements, we are going to implement those requirements and update our product. And then, of course, based on these needs, we may have to do this process again to evolve our software product. Now, as the software development is a systematic effort to produce software-intensive products, software projects require planning. And in the planning phase, numerous factors are considered to identify the optimal way to complete the project. As you can guess, there are many different types of software and they all serve a different need for different and various customers. Therefore, we have to analyze their needs and we have to plan accordingly. So what are these factors? These factors include what the customer and the user want, need, and desire, the product to be developed, the schedule required, the technologies available, and the human resources available and the skills needed. As you can see, there are many factors that goes into the planning phase. So based on these factors, we are going to choose a suitable development model, and then we are going to develop the software based on these different factors. Now, the planning activities are not one-time efforts. It's an ongoing series of activities throughout the project. While in the figure, even though we showed that the planning is on one bullet, but actually throughout the development, we may do replanning based on the issues that may arise during the development process. So in software projects, after the initial project plans are developed, the project plans are revised as necessary in the following phases. Now, the outputs of the planning activities are various types of plans related to project. An important document developed throughout the planning phase is the project vision document. It's an essential document that entails the vision for the project. Without a vision, without knowing what we want to achieve with the software product, we will not able to achieve the successfully satisfy the needs of the customer. Among the most important plans developed in this process is the software development plan or software project management plan. Now, the project management plan includes the main application features, the budget, the schedule, the risks, the stakeholders, the project organization, the communication issues, and any other information related to successfully complete the project. As you can see, there are many issues that needs to be planned throughout the software development process. Therefore, planning phase is crucial for the successful completion of the project. Now, in the analysis phase, the application domain is analyzed. Interviews are conducted with the customers and users, and the requirements are developed during this phase. Planning and analysis activities go hand in hand, and based on the discoveries during the analysis phase, the plans may be updated for an optimal solution. As we discussed earlier, the planning phase is actually spent throughout the process. Therefore, if new knowledge are discovered about the software that are going to be developed, we may replan or we may revise our plans for the software project. And the analysis and planning phases are crucial for software projects. During these phases, what is to be developed, what kind of resources are required, how long the project will take, how the product will be verified and validated are investigated and decided upon. Now, research studies indicate that fixing requirements errors later on in the process costs significantly higher compared to identifying and fixing them during the analysis phase. That's why we want to identify potential errors or potential mistakes during these phases, and especially requirements errors. Therefore, while an important portion of the analysis activities is conducted in the early phases, the analysis activities are actually spread throughout the process. And what kind of analysis and which analysis will be conducted at which phases depend on the project necessities and plans. And among the most important outputs of the analysis phase is the software requirements specification. In this document, we are going to detail what the requirements for the project are. Now, in the design phase, we are going to design based on the requirements. And a design that can satisfy the project goals and product requirements is developed during this phase. And the outputs from the analysis phase are the main inputs for this phase. Design of similar applications are also investigated again during this phase. Among the most important outputs of the design phase is the software design description. Sometimes this document is also called software design document. Depending on the project, the design phase may include an architectural design, a high-level design, and a low-level design. As you can see, we do not have one design, but we gradually expand the design, detail the design in various levels. There's a hierarchical dependency between these different levels of designs. The architectural design guides the development of the high-level design, and the high-level design guides the development of the low-level design. As we discover more about the features of the software and about the needs for the customer and about the technology that we are using, we are going to detail these designs at each iteration. So an iterative process generally takes during the design phase. At each level, the detail of the design increases and more aspects of the software are being developed or discovered. Now, there are architectural patterns developed that can guide software architects. Some of the commonly known software architectures are layered architecture pattern, client-server architecture pattern, master-slave architecture pattern, model view controller architecture pattern, broker, and pipe and filter architecture pattern. Different software architectures were developed and are being developed based on the developing needs. Now, there are other architectural patterns, and patterns are proven design solutions for various needs. Therefore, it's important to learn about these patterns, and these topics are discussed in various software engineering courses if you want to learn more about these architectural patterns. Now, in software projects, software architects develop software architectures based on these patterns. After the architecture is developed, the software designers develop the software design following the software architecture. In most cases, the designers develop the design based on iterative process. A portion of the high-level design is developed, and the related low-level design is developed. This is a circular process until all designs are completed and the designers are satisfied with the maturity of the design. Now, during the implementation phase, the code is developed based on low-level software design. In most cases, the implementation is an iterative process, just like the design process. A portion of the design is implemented that accomplishes a set of features and satisfies a set of requirements. Now, the output of the implementation phase is the software code, and the software designers and software coders are responsible for ensuring that the code follows the design. Here is a question to think about. Why do we have multiple programming languages? Why not have just one language, one programming language that we can use for many purposes? Well, the answer to that question is because different programming languages have different strengths and weaknesses. And depending on the project, multiple programming languages may be used for different portions of the implementation. A good example is web development projects. In the same project, we may use HTML, CSS, and C Sharp. And HTML, hypertext markup language, may be used to structure our web pages, to put some pictures, to put some writing on the web page. And with CSS, we may format or color the pages. And with C Sharp, we may add some programming functionality with it. As you can see, all these languages have different strengths and weaknesses. Therefore, in the same project, we use different programming languages for different purposes. Now, a discussion may be considered for HTML and CSS as there may not be a programming language, but this is just to give an example that multiple languages may be used in software project, and that's one of the reasons why you learn about multiple languages during your college education. Now, most current web applications follow the model view architectural pattern. And remember, we talked about that there are different architectural patterns used for different purposes. And this is one example in which a particular architecture pattern is used on most web application developments. In most projects, the software developers and coders are responsible for conducting unit tests that ensure that the software unit or module developed by the developer does not have software errors or bugs working as a single unit or a module. Now we have more further testing activities, but a portion of the testing is conducted by the developer itself. And there are testers in software projects that test the bigger portions of the software as a whole, as an integrated unit. Now, after the code is developed, the testing and integration phase begins. And in this phase, the software codes developed and tested as a unit are integrated with other modules and tested together. After all modules are completed, the system is tested as a whole, and integration tests are conducted. After all integration tests are conducted, the system test is conducted, ensuring that the whole systems work as intended without a problem. Now, in this phase, mostly testers, if the company or institution have software testers, they will conduct the testing and integration phase for the software project. There are various types of software tests that are conducted depending on the needs of the project. Here are some of the tests: performance tests, stress tests, user interface tests, regression tests, reliability tests, security tests, safety tests. Of course, you may guess that there are other types of tests that we may conduct, but these are the most common ones that you may hear about during software developments. After the testing and integration phase completed, we deliver the product to the customer. And after delivering the product to the customer, the maintenance phase begins. And the maintenance phase ends when the product is decommissioned or the product is no longer used by the customer. So that's the life end of the software product. As the users interact with the system in the operational environment, they may request changes or enhancements in the system, in the software system. And the developers try to continually satisfy the customer by responding these customer requests. As a result, as requirements change, there is pressure to keep the product up to date. As long as developers satisfy these requests, the product is used. Otherwise, the product becomes obsolete after a certain time, requiring the development of a new product. Okay, let's talk about one of the software development lifecycle models. We are going to talk about the waterfall model in this lecture. As we noted earlier, there are other models, and the reason that we are talking about the waterfall model, it's one of the simple and it's one of the earliest software development models that are being developed. Now, the software models does not age actually. They are just used when they are needed. And this waterfall model is described by Dr. Winston Royce in 1970 with the paper titled Managing Development of Large Software Systems. And this paper is based on his experiences in the development of a large software projects. Now, even though this is one of the earliest model, it's still in use today. And when the conditions arise, it's a successful model that we can use for developing software models. And as I mentioned, the reason that we are focusing on the waterfall model, it's a simple model and it's a good introductory model to learn about the software development process. And it has distinct phases, just we talk about up until this during this lecture. When the waterfall model is applicable to the project, then the waterfall model still produces effective results. The waterfall model includes a linear series of phases, and it's a documentation-heavy project model. Why is that documentation heavy? Because normally the waterfall model is developed for large-scale projects. And in large-scale projects, in many cases, there are many developers that are working for the project, and communication may become a challenge. That's why the documentation is used to communicate and collaborate among the developers. Now, the model specifies that the activities related to a phase should be completed before moving on to the next phase. That's why it's a linear model. And the phases in the linear order are system requirements, software requirements, analysis, program design, coding, testing, and operations. Here is a graphical illustration of the waterfall model. We first start with the requirements, then based on the requirements we develop the design, and based on the design we code or implement our application, and then we are going to conduct tests on the application to ensure that it satisfies the customer needs. And after the testing phase, we are going to deliver it to the customer. Now it's going into the operation phase and as well as maintenance phase. A software artifact is any item developed within a software project. Now, this is a common software term that you are going to hear in software development efforts. And any item that's developed within a software project is basically called a software architect. So plans, requirements, designs, codes, prototypes, simulation, test cases are all called artifacts in software engineering. Now, each phase ends with developing and approving related software artifacts for that phase. This is one of the essential or unique aspects of the waterfall model. For example, the waterfall model requires that requirements are developed before transitioning to the analysis phase. In this sense, the waterfall model is not much flexible, and this is one of the main drawbacks of the model. Here is a depiction of the waterfall model with certain software artifacts presented. The waterfall model requires that each phase ends with the development of a particular set of documents, and these documents need to be approved before transitioning into the next phase. For example, the requirement phase ends with developing a requirements document, and this document is approved before moving to the next stage, which is the design phase. And the design activities ends with developing a design document. And this document is approved before transitioning into the coding and implementation phase. Now, the coding and implementation phase ends with the software code itself. And then we are going to use that as an input for the testing phase. And the testing phase requires the development of a software testing document. And after the testing phase is conducted, we will have software test reports, which are used to determine whether the software developed is ready for deployment. And of course, during the operations and maintenance phase, there may be change requests that will be used to initiate new, smaller processes for further enhancing the product. Many practitioners who do not have an in-depth knowledge about the waterfall model may think that the waterfall model do not have feedback loops, but actually the waterfall model has feedback loops to earlier phases. If an error or an issue is identified in one phase and the cause of the error or the issue is related to an earlier phase, the developers go back to the necessary phase and fix the cause of the error. Then, the developers update all the related artifacts to reflect the current state of the product. So what could be these artifacts? These may be the requirements documents, the design documents, the test documents, the software code itself. Even though changing an artifact is not easy in the waterfall model due to the approval processes, because sometimes the approval process may take some time, but it's possible via the feedback loops. Let's say we identify an error during the testing phase. Then we may go back to the coding phase, and in the code, in our software code, we fix that problem, and then we are going to test our newly revised version of our software. Let's say during our coding phase, we identify an error related to the design. Then we may have to go back to the design phase, redesign that module. Then we are going to code based on the revised design. So the waterfall model has feedback loops to earlier phases. If we identify an error or an issue in one phase, we go back to one earlier phase and fix the cause of that error. Depending on the case, we may have to go back to more than one earlier phase, and this is determined based on the analysis of the issue or the error. So here is an example. Let's say we identify a problem in our testing phase, and then when we analyze the problem, we determine that it's related to the design. So rather than going back to coding or implementation phase, we may directly go to the design phase and redesign that module or redesign the necessary part of the software product. Then we are going to update or revise our code. Then the new revision will be tested. Now the waterfall model is actually good for certain cases, is actually quite efficient and effective for certain cases. For example, if the requirements are known and stable, the waterfall model is a good approach for developing software. And this is due to the feedback loops. Assume that if we do not know the requirements very well, and then remember that each phase ends with developing a document and approval of those documents. So if there are many requirements are changing during the process, we may have to go back all the time, which will take time and effort to redesign the software. So that's cumbersome, that requires a lot of effort. But let's assume that if the requirements are stable and known, then we may just develop the software in one phase or with limited or smaller number of feedback loops. Then the process becomes quite efficient. And also, it's a simple, easy to follow model. What should be developed at each stage is clear. If we go back to our earlier pictures, we are seeing that the requirements ends with the requirements document. The design phase ends with a design document. The coding phase ends with the software code itself. The testing phase ends with software test reports. So the process is easy to follow, and the documents or the necessary artifacts that are going to be developed at each stage is quite clear and simple. If the project team is large, in the waterfall model, synchronizing the project team members based on clear project milestones is easier compared to other models. And especially managing large-scale software projects are challenging. Therefore, having a simple, easy-to-follow model helps in managing the project. So if we take a look at the waterfall model, if our team is large, then there will be multiple teams working on various portions of the software. So we may tell everybody, all the teams, that the requirements document are due at certain time. And again, this is similarly the case in the design phase, that we may tell all the teams that the design document is due at certain time. So everybody can synchronize themselves, can synchronize their work with each other to end a particular phase. Therefore, this is one of the strengths of the waterfall model. And also, waterfall model is clear and may have simple milestones that everybody can understand, can synchronize their work, can collaborate with each other effectively. Now, the factors related to software projects differ from project to project. So what are the factors related to software projects? They are the project or product size or scale, whether the requirements are known and stable or not, because we may have some other software models that are more suitable when the requirements are changing. For example, we do have rapid system prototyping model where we do not assume that the software requirements are known or stable. With developing prototypes, we may uncover requirements, and in each iteration, we may revise our software product to reflect the newly uh, requirements. And for example, agile methods are also one of the models that embrace the requirement changes. But there are some other models, such as iterative and incremental model, that we assume a certain level of requirements are known and certain level of requirements are stable. Now, the customer may also request us to follow a particular software model. Then that becomes a contractual constraint for choosing a particular model. Again, the project team or organization size may be a factor to determine a particular software development lifecycle. Waterfall model, iterative and incremental model, or there are some other models that can embrace larger team size, while agile approach or rapid prototyping approach requires that the project team or organization size is not large or small, or at most to mid to small scale projects. And some models embrace risk. For example, the spiral model assumes that the project is risky and the project involves a number of risks. Therefore, the spiral model includes risk assessment phases. Now, also the habitual and established organization approach for software development among the project team is also a factor. For example, if our team is accustomed to use the waterfall model, then we may prefer this model over others. Or if our team is based on has a habit of developing projects in an agile manner, then we may choose agile methods over others. Of course, we have to do a trade-off between certain other factors such as the project or product size or scale, or the project team and organizational size, or based on the project risk. The model complexity and the management overhead due to the complexity is also another factor. As we mentioned, the waterfall model is quite simple to follow, but the spiral model is quite complex compared to the waterfall model. Or the agile model is not clear as the waterfall model. So the model complexity may also be an issue if our team is not trained for a particular model. Therefore, there are also other factors that may affect our choice in choosing a particular software development lifecycle model, and you will learn about these in the related software engineering courses. Choosing a suitable model for the problem at hand is crucial to be successful in software project development. Therefore, first, analyze the condition and constraints of the project, identify the factors that can affect the software development process, choose an applicable software development lifecycle model, and apply the model and customize as necessary. There are various models that are more suitable to certain conditions. If the model the team chooses is not appropriate or applicable to those conditions, then the team may face certain difficulties. And even sometimes the team may face failure due to not choosing a particular, the correct or the most applicable model for that particular problem at hand. Therefore, choosing the right software development lifecycle model is crucial in achieving success in software projects. This is the end of our module.